Okay, calculus friends, here's the second related rate video for the day. All right, so this time the two examples are going to be right triangle examples, so I'm calling them Pythagorean related rates. Okay, I hope you have something else than these, but here's this one. So Pythagorean related rates, you've got an 8-foot ladder leaning up against a wall, and the top of the ladder is sliding down the wall at a rate of 2 feet per second. How fast is the bottom of the ladder moving along the ground at the point in time when the bottom of the ladder is 4 feet from the wall? Okay, so the first thing I do is I drew a picture. Of course, I always draw a picture. So I've got my right triangle. I have 8 feet is my ladder, so I labeled that 8. I knew that the bottom of the ladder was starting 4 feet from the wall, so I'm calling the vertical side y because y is always the vertical side. So I found out how large y was when I started. And so I don't know if you noticed this, but this is actually a 30, 60, 90 triangle, which some of the problems, I'll do one more video, maybe today, where the angle is changing. And so if you can imagine, if this is my angle theta, you can imagine that that's going to be changing as well. And so sometimes we want to find out how the angle changes. Now that's a 30-degree angle because this side over here that I just retraced is half of the hypotenuse. So, oh, that's a 60-degree angle, sorry. This angle up here at the top is half, is 30, because the sine of 30 is a half. Anyway, sorry. But we're not doing that right now. We're just trying to figure out how fast the top of the ladder is sliding down the wall, how fast no, we're trying to figure out how fast the bottom of the ladder is moving along the ground. Okay, so, oh my goodness, this is terrible. I should really start over, but I can't be bothered today. So here we go. I labeled things. I've got a vertical side. The vertical side is sliding at a rate of 2 feet per second, and it's going down. So those of you that have physics, Haley and Ethan, I think you've both had physics. Since it's going down, we're going to call that a negative number, okay? Now, as that's going down, the bottom of the slide is going to the right. Usually that's a positive number, so it's okay. But we don't know what the speed is. We do know that the vertical side is starting at 4 radical 3. The horizontal side is starting at 4, and the hypotenuse is 8. And now notice the hypotenuse doesn't change lengths because it's a ladder. And the ladder is going to be constant, okay? Keep that in mind as we do this. Okay, so I wrote my Pythagorean theorem, x squared plus y squared, and I used the letter C for the hypotenuse, because that's what we often use for the hypotenuse. Now I'm going to take the derivative with respect to time. So this is going to be 2x dx dt plus 2y dy dt equals 2c dc dt. Now, I got a mistype here. I said y, but this should be a t, dy dt. Now notice everybody's got a 2. So we can divide everybody by 2 so we don't have so much messiness, okay? So I'm going to divide everybody by 2, and because I'm being super lazy, I'm just going to copy it here, and then I'm going to erase my 2's. Okay, now we also said that the hypotenuse length is not changing. So this right here, this dc dt, that's 0. That's got to be 0 because it's not changing at all. So this whole side here, regardless of how long the ladder is, which is 8, but we don't care because it's not changing. So that whole right side there is 0, and that's kind of important. So now let's plug in what we know, okay? So the horizontal, which is my x, I don't know the speed, but I know it starts at 4. So this is going to be 4, and I'm looking for dx dt because I'm looking for the horizontal. Plus, my y was 4 radical 3, and it was changing at a rate of -2 feet per second. So this is -2 over here. So now I have 4 dx dt minus 8 radical 3 equals 0. So now I'll add 8 radical 3 to both sides. So 4 dx dt is equal to 8 radical 3. And then divide by 4. So dx dt is equal to 2 radical 3. And that's going to be feet per second. Okay? So that's that one. This Pythagorean theorem. The cool thing about Pythagorean theorem is that those 2's always go away. So sometimes if you look up on the internet, they won't even bother to write the 2's when they do the derivative. They will automatically have canceled them out. I found that when I was looking for some examples. Okay, so here's example number 2. 2 cars, one going east at a rate of 90 kilometers per hour and the other going due south at a rate of 60 kilometers per hour, are traveling toward the intersection of the 2 roads. So I drew a little picture on the left. You can kind of look at that. One's going to the east, one's going to the south. At what rate are the cars approaching each other? Now, those of you that had physics, Haley and Ethan, I believe both of you, notice these are vectors. And remember, when we add vectors, we add them head to tail. So I took this picture here that I had, and notice those 2 vectors were going to be head to head. And that's bad. So I don't want that. So I moved them so I have this lovely right triangle here. Notice this is the east. This one here is the east guy. This guy is going east. This guy is going south, and they're approaching the intersection. Now, unlike the other one, everybody is changing, okay? And we're actually looking for how fast C is changing with respect to time. All right, so then I did what I did before. It said here that the east car was 0.2 kilometers from the intersection, so I did this. And the south car was 0.15, so I did this, and I looked for C. So I found C to be 0.25. So I put that over here in, oh, I didn't. So here we go. Now we're going to take the derivative. Keep this in mind. So I do the derivative. I have 2x dx dt, always with respect to time with rates, 2y dy dt equals 2c dc dt. Okay, so now I'm going to cancel out the 2's and rewrite them. So copy, and I'm going to just erase my 2's. Okay, so now x. X is the east things. So I'm going to put in these east things. The first car, the east things. So 0.2 is x. So 0.2 is x. And dx dt, he's traveling at a speed of 90 kilometers per hour. So this is 90 kilometers per hour. Plus y. Y is 0.15. So I'm going to put that in here, 0.15. How fast is he going? He was going 60 kilometers per hour. The hypotenuse was 0.25, and we want to know what is dc dt. That's our goal. Okay? So I do this, and I get 0.2 times 90 plus 0.15 times 60. I type that into my calculator, and it gives me 27. So 27 equals 0.25 dc dt. Now you can use whatever letters you want. It doesn't make any difference. Now I'm going to divide both sides by 0.25, which is the same as multiplying by 4, and I end up with 108 kilometers per hour, because that's what all the other rates were, is my dc dt. That's how quickly my hypotenuse is changing, which is pretty fast, right? Think about that for a little bit. So anyway, all right, well, I'll give you some homework in a little bit, but watch this video again if you have to.